See Standard 12th Maths, Chapter 6, Applications of Vector Algebra, XII 6.5, Sum 3. If the two lines x minus 1 by 2 equal to y plus 1 by 3 is equal to z minus 1 by 4 and x minus 3 by 1, y minus m by 2 is equal to z intersect at a point. Find the value of m. So these two lines are intersecting line. They intersect at a point. So in that case you find the value of m, unknown value here, m you have to find. So you take the first line, x minus 1 by 2 is equal to y plus 1 by 3 is equal to z minus 1 by 4. So this line passing through the point here, x1, y1, z1 I take, that is equal to, here minus 1, so you will take plus 1. Plus 1 is minus of minus 1, so minus 1 plus 1. 1 minus 1 plus 1. And the parallel vector, so the denominator are the direction ratios here. So components of the parallel vectors b1, b2, b3, that is 2, 3, 4. Take the second line, x minus 3 by 1 is equal to y minus m by 2 is equal to, see no term with the z, so just let me take z minus 0, but denominator you will get that as 1. So this line passes through the point x2, y2, z2, that is minus 3, so you will take plus 3 minus m plus m comma 0, 3m 0. And the denominator terms are direction ratio. They are the components of the parallel vectors. Let me take that d1, d2, d3. This is equal to 1, 2, 1. Okay. So since the two lines intersect, so they given in page 252 in your book, the remark part. Since the two lines intersect, the determinant value x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, parallel vectors, b3, again d1, d2, d3 is equal to 0. That is determinant value. You substitute the value x2 minus x1. So x1 is 1. So 3 minus 1. 3 minus 1, that is equal to 2. y2 minus y1. y2 is m. y1 is minus 1. So plus 1. m plus 1. m plus 1. Same thing z2 minus z1. 0 minus 1 is minus 1. Then substitute the value of b1, b2, b3. 2, 3, 4. 2, 3, 4. Then d1, d2, d3, that is 1, 2, 1. This is equal to, you will get 0. Now we will solve the equation, solve the determinant. So 2 into, first term, 2 into, leave up the row and column. 1 3s are 3 minus 4 2s are 8 minus m plus 1. Leave up this column and the row. 1 2s are 2 minus 1 4s are 4 minus 1 into 1 2 2s are 4 minus 1 3s are 3. This is equal to 0. So 2 into minus 5 minus m plus 1 into minus 2 minus 1 into 1 is equal to 0. Minus 10. Then minus into minus plus 2m. 1 2s are 2 minus 1 equal to 0. So 2m is 2m minus 11 plus 2, that is minus 9 equal to 0. So 2m equal to 9. So m equal to 9 by 2. So the value of m equal to 9 by 2. So this is what you have to find. Find the value of m. Okay, next question, fourth one. See the fourth sum. Show that the lines x minus 3 by 3 equal to y minus 3 by minus 1, comma z minus 1 equal to 0, and x minus 6 by 2, z minus 1 by 3, comma y minus 2 equal to 0 intersect. You have to show the two lines intersect. Also find the point of intersection. Here two questions arises here. First one is you have to show these two lines are intersecting lines. Second question, you have to find the point of intersection. First let us answer for the first one. We are going to show the two lines are intersecting line. So same thing as you have seen in the previous sum. So let me write in the first equation the coordinate form x minus 3 by 3, y minus 3 by minus 1. Here equal to is not given, it's given as z minus 1 equal to 0. Let me take this is equal to, so denominator you bring the 0 to this side. So z minus 1 by 0. Here the point x1, y1, z1 is equal to, take minus 3. So this is plus 3 and 1. Then parallel vector b1, b2, b3 is equal to the denominator direction ratios 3, minus 1, 0. Now take the second line. The second line is x minus 6 by 2 equal to z minus 1 by 3, comma y minus 2 is equal to 0. So you take this is equal to y minus 2 by 0. Y minus 2 by 0. So for this the point is here x2, y2, z2 is equal to 6. Take the y coordinate here. y2 is here 2 and then z2 is 1. 6, 2, 1. Then parallel vector d1, d2, d3. That is 2, 3, 0. This is the parallel vector. See one small correction here. You have to write the y value here first. Denominator here 0, then for z you will get 3. Okay. So the condition to show the given equations are intersecting. So you have to show x2 minus x1, y2 minus y1, z2 minus z1, then b1, b2, b3, d1, d2, d3. I have to show this is equal to 0. To show this is equal to 0. So take x2 minus x1. 6 minus 3 is 3. Then 2 minus 3. 2 minus 3 is minus 1. Then z2 is 1. z1 is also 1, 0. Then b1, b2, b3 is here. b1, b2, b3. 3 minus 1. Again you will get 3 minus 1, 0. What about d1, d2, d3? 2, 0, 3. So that is equal to, here you will get here 3 into, just you do the calculation. Here you can take with respect to this column. So both the elements of 0. So just take 3 into minus 3, minus of minus 3 plus 3. So you will get answer 0. So the given lines are intersecting lines. Lines are intersecting lines. Intersecting line. That means they intersect at a point. So the two lines intersect at a point. Now we have to find the intersecting point here, O. So for that let me take again you have to find the point on the two lines. The point on the two lines so that both the points are same, equal. So x minus 3 by 3 is equal to y minus 3 by minus 1 is equal to z minus 1 by 0. Let me take that as some t. So find the point. So x minus 3 by 3 equal to t. So 3t plus 3, first coordinates 3t plus 3, comma, minus t plus 3, then 0, minus 1 plus 1, so you will get 1. So this is the first coordinate, and take the second line, x minus 6 by 2, take the y value, y minus 2 by 0 is equal to z minus 1 by 3. Let me take this as s. So the point is here x 2s plus 6, 0 plus 2, 3s plus 1. See, the 2 points are intersecting point and both are same. So equate the corresponding terms. Here this is x value, both are same, and this is y value and this is z value. So let me take here, you can take you can equate any values here. See, minus t plus 3 is equal to 2. So minus t is equal to 2 minus 3, minus t equal to minus 1, t is equal to 1. So take the z value here, 3s plus 1 is equal to 1. So 3s is equal to 1 minus 1, 0. 3s is equal to 0. So s is equal to 0. You substitute in the coordinates. See, substitute t as 1. If I substitute t as 1, 3 plus 3 is 6. 6. And take t as here 1 minus t plus 3, that is 2. Then z value is 1. So same value will get if you substitute in this s value here. Both the values are same. So this is the intersecting point. So the intersecting point is 6, 2, 1. So the two lines are intersecting at the point 6, 2, 1. See the seventh question. Find the foot of the perpendicular drawn from the point 5, 4, 2 to the line x plus 1 by 2 equal to y minus 3 by 3 is equal to z minus 1 by minus 1. Also find the equation of the perpendicular. So you have to find, see the point, let me take a point, given point as D. See the coordinates are 5, 4, 2. So from this point I draw a perpendicular line to the line here. This is our given line. See, x plus 1 by 2 is equal to y minus 3 by 3 is equal to z minus 1 by minus 1. So I draw perpendicular line from this point D. So let it meet at a point F. At a point F. So I have to find the coordinate of F here first. Two questions arises here. Find the foot of the perpendicular. So I am going to find F first here. And then also find the equation of the perpendicular. Also find the equation DF. First you find F. Okay. So this is the given line. So here this x plus 1, y minus 3, z minus 1. So minus 1, 3 plus 1 are the coordinates on the point on the line, but this is the parallel vector. 2, 3, minus 1 is a parallel vector. This is parallel to this line. That is vector B is equal to 2i plus 3j minus k. This is the parallel vector for this line. Okay. See, here we know D is here 5, 4, 2. And what about here F? F is a point on the line. So what about the coordinate of F here? So let me take this is equal to T. Therefore, the coordinate of F are here x plus 1 by 2 equal to T. So 2T minus 1, 2T minus 1, 3T plus 3 y coordinate, then minus 1 into T minus T plus 1. So this is the F coordinate. So take this DF segment here, DF according to the vector formula, this is OF, position vector of F minus OD. So OF here 2T minus 1, 2T minus 1 minus 5, that is, see, just you write as the vector form. This is the point form. So let me write as the vector form 2ti vector I plus 3t plus 3 into j plus minus t plus 1 into k. So minus 5i plus 4j plus 2k. So just do the calculation. I with I, 2t minus 1 minus 5 is minus 6i vector. 3t plus 3 minus 4. 3t minus 1 into j vector. Minus t plus 1 minus 2. That is minus t minus 1 into k vector. So this is our DF vector. So but here this DF is DF. So you have to find the point F only here. See, DF and this B vector, parallel vector, are again perpendicular. See, again these two vectors are perpendicular. That is B vector and DF are perpendicular. So the dot product is 0. Vector B dot DF is equal to 0. So what is B vector here? 2i plus 3j minus k dot this. See, B vector is 2i plus 3j minus k into dot 2t minus 6 into I vector plus 3t minus 1 into j vector plus minus t minus 1 into k vector is equal to 0. So you find the dot of corresponding I dot I. 2t minus 6 into 2 plus 3 into 3t minus 1 plus minus 1 into minus t minus 1 equal to 0. So just do the calculation. 4t minus 12, 9t minus 3, minus into minus plus t plus 1 is equal to 0. So here 14t minus 15 plus 1 minus 14 is equal to 0. So 14t is equal to 14. So t is equal to 14 by 14 is equal to 1. So take 1, t as 1, substitute in the f. We need to find f for the first question. So the f coordinate is, substitute t as 1 here. So you will get 2 minus 1 is 1 and 1 plus 3 6. Then minus 1 plus 1 you will get 0. So the coordinate of F are 1, 6, 0. Therefore, the foot of the perpendicular line from D is here 1, 6, 0. Now we have to find the equation. Second question, equation of DF, perpendicular line DF. We know D as here 5, 4, 2 and F is here 1, 6, 0. So take this is x1, y1, z1, x2, y2, z2. So the equation in the coordinate form, Cartesian form is x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. So x minus x1, so x minus 5 divided by x2 minus x1, 1 minus 5, that is minus 4. Y minus y1 is 4 divided by 6 minus 4 is 2 here. Then z minus z1 is 2. z2 minus z1, 0 minus 2 is minus 2. So this is the equation of the perpendicular line DF. It's a perpendicular line. Perpendicular line DF. See, thank you. All are of the same model, the 3 sums. Thank you.